Hi, welcome to the fourth part of the Assembly Language Primer for Hackers video series. I thank you all for the encouraging comments which you left behind for the last three videos. Please keep the comments coming because that is what encourages me to make more videos. So in this fourth part, we will look at how to code your very first assembly language program. Before we begin into the actual coding exercise, let's look at the structure of an assembly language program. So when you code in assembly, you need to organize your program in a particular way. And what we shall do is actually make sure that we divide the program into various segments. So the first being the .data segment. This is where in this section you mention all the initialized data. So let's say if you want to declare a hello world string, this would be the place where you would declare that. The next segment is the .bss segment. This is where all the uninitialized data is generally declared in the assembly language program. Then you have the actual .text segment, and this is where the program instructions are written. So this is the actual executable code which you would actually write, saying do this and do that. Now, when you write these program instructions, there needs to be a place or a specific label where the assembler would actually know that this is the start of the assembly language program. And this is described using the _start label. So you can actually compare this with the main routine in a C program. Now, along with this, what you need to mention is a .global global label, using which you can go ahead and declare that these are the external callable routines. So this is where, let's say if you had written library, you would expose all those library functions which you want exportable, and so that other programs can call them and use them. So this is a very simple structure. There are a couple of other segments which could also be there. However, for the time being, for simplicity, let's ignore them. So now let's move on and discuss a little bit about Linux system calls. So what are Linux system calls? You could think of the system calls as a library which the kernel exposes to user space programs for various activities which they can do. Now, an exhaustive list of all the system calls is present in the user include asm unistd.h file. Examples of system calls would be the exit call, the read, the write calls, and many others which you are familiar and probably have used in your C programs. Now, the important thing to note is that system calls are invoked by processes using the software interrupt 0x80. Now, when this interrupt is actually invoked, then the kernel calls the suitable system call interrupt handler, which goes ahead, takes all the arguments, and then just does whatever is required based on the system call number, which defines what that call is all about. So it's a very basic background. I'm trying to keep it simple. There is much more to be discussed about system calls, but we'll do that in later videos. So the other thing which needs to know is that, let's say there is a system call such as exit or read, then you would need to pass arguments to that system call. Now, how do you do that in assembly? Now, this is where all the registers, the CPU registers which we spoke about in the first video come in. So whenever you are going to invoke a Linux system call, you need to load these registers with the appropriate arguments which the system call will require. So it's almost a general rule that EAX register will contain the system call number. And we'll get into what that is a little later. EBX would contain the first argument, ECX the second, and so on and so forth. Generally, for system calls which require more than 5 arguments, we go ahead and pass a pointer to structures containing those arguments. However, let's not complicate things for the time being, and we will look at them a bit later. So let's take an example of how a system call would be invoked through assembly. So let's take the exit call. Now, all of us know that exit is generally called to exit the program. And the way the function is actually defined, the system call is defined, is that you go ahead and pass it an integer, which is the status. Generally, that could be 0, 1, or -1, depending on what you want to convey to the environment about how the program exited. Now, in order to translate this into assembly, there are a couple of steps which we need to follow. The first, what we need to do is find the syscall for exit, syscall number, and that is 1. In the next couple of minutes, I'll show you how I found out that the system call number for exit is 1, but let's keep it as is for the time being. So as we remember from the previous slide, is that the syscall number needs to be loaded into the EAX register. Now, how do we do that? We use the movl assembly language command for that. And because we want to load the number 1, that is described by $1. Now, do not worry, we will get into all the assembly language instruction set and everything in later videos. This is just so that we can begin with programming. Now, the move instruction actually loads the value 1 into the EAX register, which is denoted by %EAX. Now, once the system call number is loaded, the next task, if we remember, is actually fill up the status value, right? So let's say the status value is going to be 0. So from the previous slide, once again, the first argument to the system call needs to be loaded into the EBX register. How do we do that? Very simply, once again, we use the movl instruction, using which we go ahead and transfer the number 0 into the EBX register. Now the third, of course, is actually going to be calling the syscall itself, and that is done by raising the interrupt 0x80. Right? So very simple steps of how to go ahead and invoke the exit system call in assembly. Now, how would a very simple program with just exits now look like? So this is how it would look like. We do not require the .data segment, nor do we require the .bss segment, because there is no data which you're going to use. We just require the text segment, and there in the start label, which is synonymous to your main function, we go ahead and mention these very simple 3 instructions. Go ahead, transfer 1 into EAX. 1 is nothing but the syscall number for exit. Then go ahead and load the EBX register with 0. This is nothing but the status value which we return back to the environment. And then finally call the interrupt 0x80 to actually invoke the syscall. So let's code this in a program and see how it looks like. So let's call the program just exit. And I would recommend that probably you should also kind of type along with me to understand things better instead of kind of leaving it for later. So that's why I'm going to kind of do this from scratch. So the first thing which we need to do is go ahead and mention the text segment. Then you go ahead and say that start is kind of the callable function from this program, and then we go ahead and mention the start label beginning. And then the first thing, if you remember, is actually transferring the value 1 into the EAX register. The next step is transferring the value 0 into the EBX register, and then finally is to call the interrupt. Right? Very simple program. Now, how do you go about compiling an assembly language program? So the first thing we do is use the GNU assembler, which is available in most Linux systems as the AS utility. We go ahead, say that it needs to compile the just exit .c program, .assembly program, and then go ahead and create an object file just exit.o. So it's done that. So now you have an object file And if you notice, I mean, there's nothing much we can do with an object file unless we have the linker actually going ahead and creating the final executable, which is the elf executable. So LD is the linker. You go ahead and say that, the output file needs to be just exit, and we give it the just exit.o object file. So the linking has been done now. And now let's run the just exit program. So if you notice, the program runs and all it does is just exits as expected. So now let's go back to our presentation. So this was the very first and simplest program one could ever write. Now let's look at building on top of this. So the next thing which you'd like to do is probably create the actual hello world program. Now how do you do that? Well, you need to go ahead and figure out which syscall can be used for actually printing something on the screen. So let's look at what would be the different steps. Now logically, if you kind of compare it with a C program, what you would need to do is probably call the write syscall in order to print the hello world message. Now don't confuse, let's say, why couldn't we use printf? Printf is part of the C library libc. We will look at how to go ahead and call various libc library functions in a separate video. Right now we are just concentrating on the system calls which are available via the kernel. So we go ahead and use the write syscall, and then of course we'll have to use the exit syscall to gracefully exit the program. Right? So how do you go about doing this? Now, the first thing one needs to understand is the write syscall description. Now, this is how it is actually defined, where it actually requires 3 arguments. First is the file descriptor into which it needs to write. The second is the buffer where the actual data to be written is stored. And then finally is the number of bytes which need to be written from the beginning of this buffer, right? So once again, what does one need to do for the syscall? The first thing is to go ahead and figure out the syscall number for write, and which is 4. Actually, let me kind of quickly go back and show you how you can find those numbers out. So as in the presentation, if you remember, user include asm unisted.h contains all the syscall numbers. So if you notice, the syscall number for exit was 1 as we had used in the previous demo, and now the syscall for write is actually 4. Okay, and you can find the syscall number for every other system call using this file. Okay, so we need to store 4 inside EAX register. Then we need to store the descriptor, which is going to be kind of the handle which it will actually use to go ahead and print the actually write the appropriate message. And what we'll do is, what we want is that, we don't want to write into a file. We very simply want to write into std out. Now, if one remembers basic Linux, then std in is file descriptor 0, std out is file descriptor 1, and std error is 2. So if you want to write to std out, then the file descriptor needs to be 1. And this is what we are going to store into the EBX register. The third is actually a pointer to the memory location, which is going to contain our hello world string. And this pointer needs to be in the ECX register. And then finally is the count or the string length of the hello world message, which needs to be stored in the EDX register. And this is exactly what we've spoken of previously. EAX, once again, system call, EBX first argument, ECX second argument, EDX third argument, and so on and so forth. Once all these registers have been loaded, in this case, write just has 3 arguments. So all we will require is till EDX. We go ahead and call the interrupt 0x80 command. So now let's go ahead, look at a hello world program demonstration. Okay, so let's begin programming our hello world program. So hash actually allows you to make comments in an assembly language program. Now the first thing we need to do is go ahead and mention the hello world string itself. Now if you remember in the presentation, all the initialized data needs to be mentioned in the .data segment. So we need to mention the initialized data here, and let's actually go ahead and define our hello world string using this hello world string label. And what we need to do is we say this is ASCII and then go ahead and write the string itself. Now .ASCII is used for defining all ASCII strings in assembly. Right, so we'll get into the data types and all that in later videos, but we just need to get started with the actual programming, or else very soon you're going to get bored with all these videos because it would be just theory. So that's not the way to do it. Let's make it interesting. So the next segment we need to go ahead and write is the text segment, which is where the actual executable code is going to be. Once again, we go ahead and define the .global, and then from here we go ahead and mention the start label itself. So the first thing we need to do is load all the arguments for write. So let's go back to our presentation. And if you notice, the first thing we need to note is the syscall number into EAX, right? And that is the value 4. The second input, the first input to the write call is going to be the file descriptor, which is going to be 1, as we are going to write the string to std out. And this should be loaded in EBX. The second argument to write is a pointer to the buffer where the string is located. Now the way to actually point to get a pointer to the hello world string is just by going and mentioning the $sign and then the label. This needs to be moved into ECX. Finally, into EDX we need to move the string length. So this would be 5 for hello, 5 for world, and a space in between, which is 11. So let's say we move the value into EDX. Right? And the final thing we need to do is go ahead and call the interrupt. Right, so this is going to write the hello world string onto std out. Then finally we need to exit the program. Right, for this we'll use the exit syscall. And from the past example, if you go back to the presentation, very simply, this is how you exit. That is, load the value 1 into EAX, which is the syscall number for exit. Then go ahead and load the value 0 into EBX, right, which is going to be the status value as discussed. And then finally call the interrupt. Right. So let's go ahead and compile this program. on the object file. Right, so we've assembled the program. Now let's go ahead and link it. Now let's actually run the program itself. So if you notice, the string hello world was printed and the program exits. I think probably we should add a /n at the end so that we get a new line. So very simple, add it here. This increases the value by a byte. So we increase the string length to 12. Assemble it, link it, and run it. So here we are. So congratulations if you had the patience to watch the video till here, and probably if you're also trying it out simultaneously on your own computer, then this is your very first program which you've successfully written, which actually does something. Your hello world program. So well, that's all for this video. I think the key takeaways need to be understanding the structure of an assembly language program, understanding how to load arguments into various registers, and number 3 is how to call syscalls. In the next video, we will look into data types and other control structures which one needs to know. Please leave behind your comments about this video, because that helps me get better in the later videos. Well, that's all for this video. Thanks a lot.